All right, welcome back to another episode of Science with Surback. Today what we're going to be talking about is section 11.3, which deals with moles of compounds. Now, a couple of objectives I want you to be able to accomplish by the end of this video are as follows. Objective number 1, recognize the mole relationships shown by chemical formulas. Objective number 2, calculate the molar mass of a compound. Objective number 3, calculate the number of moles of a compound from a given mass of the compound and the mass of a compound from a given number of moles. And objective number 4 is determine the number of atoms or ions in a mass of a compound. So let's go ahead, let's get started with our business here about how can we use the mole and relate it back to chemical formulas. So it's really interesting when we actually perform or we actually write down a chemical formula. What we're actually doing is we're indicating the numbers and types of atoms contained in one unit of the compound. Now, a really important point here is this. The ratio of atoms in a compound is equivalent to the ratio of moles of different elements in that compound. So let's take this into an example of the compound Freon. Now, Freon has the chemical formula of CCl2, F2. And so what we've learned about before with chemical formulas is this. That chemical formula here for Freon represents the number of atoms in this particular compound. So in this compound, when we're just talking about number of atoms, we have one carbon atom. The subscript 2 to the right of Cl represents that we have 2 chlorine atoms. And again, the subscript 2 behind our F, or fluorine, represents that we have 2 fluorine atoms. Okay, so that was one molecule of Freon. Let's say instead of having one molecule, let's say that we have 1 mole of a Freon molecule. So if we have 1 mole of a Freon molecule here, we are going to have 1 mole of carbon atoms. We will have 2 moles of chlorine atoms, and we will have 2 moles of fluorine atoms. So the point that I'm trying to make here is that the ratio of atoms in a chemical formula can also be equivalent to the number of moles of that particular atom if we're talking about the unit of moles. So what I'm saying here is that the subscript becomes very important in the chemical formula because it can help us go from these formula units or these molecules to specific moles of our compound. And we can break it down into further and further detail. So let's go ahead, let's get some steps to be able to convert from moles of a compound to individual atoms or individual elements here. So we start out here with our first step. And our first step is to write down the given amount of moles of the compound. The second step is to determine the number of moles of the individual element to 1 mole of the compound. In other words, this is saying determine the mole ratio of the compound. The third step is to set up the conversion factor. And then the fourth and final step here is to calculate and make sure you include your units in the answer. And that should be in moles of the element that you're trying to find or work with. So let's try this out in an example. We want to determine the number of moles of just aluminum ions in a 1.25 mole sample of aluminum oxide. Now before we get into the problem here, we need to think about the formula for aluminum oxide. And I'm going to go kind of quickly, but remember you always have that periodic table packet. So Al Al is the symbol for aluminum, and if you look up aluminum's charge, it has a 3+ charge. Now, oxide is the name given to the oxygen ion, so we write down O, and again, you can look this up, but O, oxygen, has a 2- charge. Now, we crisscross the charge number to find out what our formula for aluminum oxide is, and Al2O3 becomes that formula. Now what we can do is we can actually start with step 1 that we just wrote down. So what we do here is we take 1.25 moles of aluminum oxide, Al2O3, and we set up our conversion factor. Now remember, with the conversion factor, we need to have the same unit diagonal from the unit that we started with. So because we had moles of Al2O3 on top, we need moles of Al2O3 diagonal. Now, we can, because we're going from moles of one thing to moles of another, we can make one direct conversion, and we're trying to, like the problem said, get to moles of aluminum, Al3+. Now, mole to mole, typically we're going to use a balanced chemical equation, but for here, what we're going to do is look at our chemical formula. So right to the left part here, I'm going to put 1 mole of Al2O3 equals the number of moles of Al. Well, the way we find that is that we look at the chemical formula. So because there's a 2 subscript behind Al, that means that there is 2 moles of Al3+ to every 1 mole of Al2O3. So our ratio here becomes 1 for Al2O3 and 2 for Al3+. So now all we got to do is get out our handy dandy calculators and calculate this out. So what we're going to do here, we are going to type in 1.25 and we're going to multiply that by 2. We press enter, we get 2.5, and then we divide it by what's on bottom. So we divide by 1, which hopefully you can see is the same thing. And so our answer here is 2.5 moles, and it's moles of those aluminum Al3+ ions. So again, all we're doing is we're going from moles of that compound and we're breaking it down into its individual elements. That's all we need to do for this particular problem. All right, so now that we have that in mind, we can get a little bit more in depth and in detail about the molar mass of a compound. So we'll switch gears here and we'll talk about the molar mass of the compound and then go over a couple examples. But we have this. The molar mass of a compound equals the molar mass of each element multiplied by the moles of that element in the chemical formula, and then we add all of those things together. Now, one important note here is that the molar mass of a compound demonstrates the law of conservation of mass. So let's go through the steps to be able to specifically determine the molar mass of a compound. So, number 1, for each element in the compound, determine the molar mass. Now, the molar mass for each individual element can be just found by looking at the atomic mass on the periodic table. So again, just as a reminder here, remember the atomic mass is that decimal number that is located underneath each of our elements in the periodic table. The second step is to multiply the molar mass of each element in the compound by the number of moles in that element in the chemical formula. So remember, that number we multiply the molar mass by is also known as the mole ratio, which we'll talk about here in a second when we actually go through an example. Now, the third step should be to add the masses together from step 2, and this allows you to determine the molar mass of the entire compound. Now, the units here should be in grams per mole. So again, we're just adding all of those elements that we've gone through and done that in step 2. Now, the units here should be in grams per mole. So let's go ahead, let's put these steps to the test in an example. So we want to determine the molar mass of potassium chromate. And in this example, I'm going to break it down a little bit more in depth and in detail here. And so what I like to do is this. I like to list out each and every element involved in this particular formula. So I have K for potassium. I give a little space here. I have Cr for chromium. And then I have O for oxygen. And we start out with potassium. The first thing that we do is we find that atomic mass. So we look here, K. We find K, and remember, we are rounding to 2 decimal places. So when you round to 2 decimal places for potassium, this becomes a molar mass of 39.10. So we have 39.10 grams per mole. And so we multiply it by the number of moles, or the number of moles in this case is just equal to that subscript. So we're going to multiply it by 2 because there are 2 moles in this particular formula for potassium chromate. So what we do now, I always like to calculate this out before I move on. And so what I'm going to do in my calculator, I'm going to put 39.10 times 2. 39.10 times 2. And that gets me a mass of 78.2 grams per mole. So we get 78.20 grams per mole. Now we go down and we do the same exact thing for chromium. So chromium has the symbol Cr. We find chromium. And it's kind of weird here because if we round to 2 decimal places, chromium rounds to 52.00. So chromium becomes 52.00 grams per mole. We look to the chemical formula to find out how many moles of chromium we have. We have 1 mole. And so again, in my calculator, I'm going to type in 52.00 times 1. So 52.00 times 1. I press enter. Hey, I still get 52. So I get 52.00 grams per mole. And then I move down to oxygen. So if we find oxygen on the periodic table, we're looking for the atomic mass, which once again, it rounds to exactly 16.00. So we have 16.00 grams per mole. And then we multiply that by the number of oxygens we have in our formula. So because we have 4 next to our oxygens, we round that to 4. So in our calculators, we're going to take 16.00, and we're going to multiply it by 4. We get a value of 64.00 grams per mole. Now, this was all step 2 in our steps we just went over. So the last thing that we have to do is this. We need to add all of these things together. So in my calculator, I'm going to take 78.2 plus 52 plus 64. So for this, we have 78.20 plus 52.00 plus 64.00. We press enter. We get a molar mass of 194.20 grams per mole. So for this 194.20 grams per mole of potassium chromate. So I'm always going to include what the chemical formula is, and that's going to help us later on down the road. But that is how we would solve for the molar mass of this particular compound, or how we would do it for any compound. Now what we can do, we can go a little bit further, and we can now use the molar mass of the compound and kind of tie in some things we did in section 2. So what we're going to do first is this. We are going to be able to convert moles of a compound to mass. So we're going to need to utilize what we just learned and pull from section 2. So I'm going to go over the steps, and then I didn't want to squeeze this on a separate page, so we'll leave that for the next page here. But to do this, to go from moles to mass of a compound, we need to, in step 1, write down the given number of moles of the compound. The second step is determine the molar mass of the compound. So step 2 here is exactly what we just showed you on that previous example. Now step 3 is to multiply the given number of moles by the molar mass of the compound. Now step 3 here can really be simplified into setting up the conversion factor. And then that fourth and final step is to calculate and show the correct unit, which will be in grams. So let's go ahead, let's put these steps to the test here and go through in an example in the next page here. So what we're going to do here is we want to determine the mass in grams of 2.5 moles of allyl sulfide, which I included the formula here in parentheses. So for this process here, it said write down the moles given. So I'm going to put this about 3/4 of the way down the page. So I have 2.50 moles of allyl sulfide, which it has the formula C3H52 and then S for sulfide. So I'm going to leave that right here because step 2 says, hey, find the molar mass of this compound. So again, to find the molar mass, we're just going to list out each and every element that is involved in this particular formula. So we have C for carbon, we have H for hydrogen, and then we also have S for sulfur. Now we do the same things that we just did a few moments ago to be able to find out the molar mass. So we look for carbon, C, and it has the molar mass of 12.01 grams per mole. So 12.01 grams per mole. We multiply it by how many carbons we have. Now we have to be careful here because this 2 multiplies this 3 that is right next to carbon. So we have 2 times 3. So that means we actually have 6 moles of carbon. Now, all I'm going to do here is I'm going to plug this into my calculator. I have 12.01 times 6, and I get a value of 72.06 grams per mole. So 72.06 grams per mole. Then I move down to my hydrogen. Now remember, hydrogen is the only element I want 3 decimal places here when I read the molar mass. So this is actually going to be 1.008 grams per mole. So we have 1.008 grams per mole. We multiply it by how many hydrogens that we have. And again, we have to be careful because this 5 gets multiplied by this 2. And so we actually have a total of 10 moles of hydrogen. Now we do the same exact thing that we did above. So we type in 1.008 times 10. We press enter. So we have 10.08 grams per moles. And then we go to sulfur. We look up the molar mass of sulfur, and when we round it, it's going to be 32.07 grams per mole. So we have 32.07 grams per mole. And then we multiply it by how many sulfurs we have. Well, we only have 1 sulfur, So hopefully everybody can see 32.07 times 1 is still going to be 32.07 grams per mole. Now the last step here to find the molar mass is we just add these numbers that we just calculated all together. So what we do is we add, or we put in our calculator, 72.06 plus 10.08 plus 32.07. We press enter. We get a molar mass of 114.21, 114.21 grams per mole of C3H5 2S. All right. So what that means is that every 1 mole, and I'm going to rewrite this, every 1 mole of allyl sulfide has 114.21 grams. So let me rewrite that right now as I'm thinking of it. So 1 mole of C3H5 2 equals 114.21 grams. And that's going to be really important in this final step. So step 3 basically is set up that conversion factor. So what we're going to do here, remember, diagonal units must cancel out. So because we have moles of allyl sulfide, we have to cancel moles of allyl sulfide on bottom. And then we can write what we want. We want the mass of allyl sulfide, so we have grams of C3H5 2S. And remember, 1 mole equals that 114.21 grams. We spent all that time calculating, so we put that in the correct spots. And so all I'm going to do is I'm going to take 2.50. So 2.50 times 114.21. I press enter. I divide it by what's on bottom. So I divide by 1, and I'm going to round to 3 total digits. So when we do this, this rounds to 286 grams of allyl sulfide. So 286 grams of C3H5 2S, and that becomes our final answer. So now we've gone one way. We've gone from moles to grams. We can now go the opposite way. So we can go from grams of a compound to moles. Okay, so now that we've had this, let's go ahead, let's convert or go to the opposite way. So what if we start out with the mass of a compound and we want to convert it to moles? Well, it's going to be very similar steps here, but the first thing that we need to do is write down the given amount of mass of the compound. Now, the units for mass here should be in grams. The second step is to determine the molar mass of the compound. Again, that's what we've been doing the past couple of examples. And so the third step is to divide the given mass of the compound by the molar mass of the compound. Now, step 3, once again, is basically saying set up that conversion factor. And then the fourth and final step is to calculate and make sure you show the correct unit. Now the correct unit should be in moles of the compound. So let's go through an example to be able to do or convert from mass to moles of a compound. So what we have here is this. We want to calculate the number of moles in calcium hydroxide, if we have a 325 gram sample of calcium hydroxide. So again, the first thing that we need to do is we need to write down what is given to us, or the mass that is given to us. And I'm going to skip a little bit and put about 3/4 of the way down the page. And so I have 325 grams of calcium hydroxide. Now what I'm going to do is I need to determine the molar mass. So once again, I list out each and every element involved in this particular formula. So I have calcium Ca, I have oxygen, and I have H for hydrogen. The next step here when we find the molar mass is to go through and determine the atomic mass. So for calcium, Ca, you look and you find Ca. Remember, we round to 2 decimal places, so we have 40.08, and that is 40.08 grams per mole. We look to the formula, and we say, hey, there is 1 calcium, so we multiply this by 1. Now remember, anything times 1 is always itself. So we have 40.08 grams per moles. Now oxygen, we first find the atomic mass. And remember, oxygen rounds to 16.00. So we have oxygen as 16.00 grams per mole. And we multiply it by the number of oxygens we have. Now it's very important. OH is in parentheses, so that means we have 2 oxygens. So we have 2 oxygens, and we go through this process here. In our calculators, we put 16.00, so 16.00 times 2. We get exactly 32.00 grams per mole. And then we do this one more time for hydrogen. Hydrogen, look up the molar mass. Now hydrogen's the only molar mass that I want 3 decimals. So in this case, hydrogen has a molar mass of 1.008 grams per mole. We multiply it by the number of hydrogens we have, which again, it is inside the parentheses with a 2 outside, so that means we also have to multiply this by 2. So when we do this, we have 1.008 times 2. We press enter, and I'm going to round this to 2 decimals, so that is 2.02 grams per mole. So once we've gone through this particular process here, all we need to do is we just need to add these together. So in our calculators, we hit 40.08 plus 32.00 plus 2.02. We press enter, and we get a value of 71.10 grams per mole. So what that means, 71.10 grams per mole, and I'm going to write this to the left, is that in 1 mole of calcium hydroxide, CaOH2, this equals 74.10 grams. Okay, now let's go and we go to step 3, which is simply just setting up the conversion factor. And so for this process here, what we do, we set up that conversion factor. Again, diagonal units need to cancel out. So in this case, we're going to cancel grams of calcium hydroxide on bottom, and we are going to go to moles of calcium hydroxide on top. And the reason we can do that is because that molar mass, that thing we just put together. So in every 1 mole of calcium hydroxide, we have 74.10 grams. So we have 1 mole associated with 74.10 grams. And so all we need to do in our calculator is, again, multiply everything on top. So in this case, it's going to be 325 times 1 equals 325. And then we divide it by everything on bottom. So in this case, we just divide by 74.10, and we press enter. Now we get 4 with a long decimal. We are going to round this to 3 total digits. So when we round this, this becomes 4.39. And the units here is moles of calcium hydroxide. So the key here to those last 2 examples is taking your time and finding the molar mass. But once we have done that, we are in the driver's seat to be able to make these calculations or conversions possible. Now what we're going to do, our last thing that we will talk about today, is converting from mass. So starting in grams and going to particles, which remember, particles were those formula units those molecules or those atoms that we've talked about before. So the steps, I'll warn you, are a little bit lengthy here, but that's because we're essentially doing 3 conversions in one. So the first step here is this: write down the given amount of mass of the compound. The second step is to determine the molar mass of the compound. The third step is to divide the given mass of the compound by the molar mass of the compound. And step 3 here is a conversion factor that you need to set up. The fourth step here is to calculate to determine the number of moles of the compound. Once you've calculated that step there, you can multiply the number of moles calculated by the number of representative particles in 1 mole. Now, as a reminder here, 1 mole of anything equals 6.02 times 10 to the 23rd representative particles. Now, the sixth step here is to calculate and show the correct unit. Now, the units here should be in molecules or formula units. And just as a reminder, molecules are associated with covalent compounds or 2 nonmetals, and formula units are associated with ionic or a metal and a nonmetal compound. Now, one important note here is that there is no direct conversion from mass to particles. I know it's a tedious process, but you have to go through steps 1 through 6. So, in our final example here, we've already started a big chunk of this, so we're going to write down what we had from the previous problem, but we're going to convert our mass to particles of a compound. So we'll switch gears here, and looky here, we want to calculate the number of formula units in a 325 gram sample of calcium hydroxide. So to do this, the first 3 steps, actually 4 steps, will be from the problem we did earlier. So what I'm going to do here is this. I'm going to set this problem up exactly how we started it last time. So I'm going to write down 325 grams of calcium hydroxide, and then I'm going to write down the molar mass of calcium hydroxide. So I'm going to write down Ca, I'm going to write down O, and H. Now, calcium, from that previous problem, calcium had a molar mass of 40.08 grams, so 40.08 grams per mole. We had 1 calcium, so that gave us a value of 40.08 grams per mole. Then oxygen from the previous problem, and all I'm doing is copying this down, but oxygen had a molar mass of 16.00, so I write down 16.00 grams per mole. From that problem, there were 2 oxygens, and when we calculated that out, that was a value of 32.00 grams per mole. Again, just copying down. Hydrogen, if I bring this down, hydrogen had a molar mass of 1.008, and I had 2 of them. So I take 1.008 grams per mole, and I multiply that by 2, and that got me a value of 2.02 grams per mole. Now I added all of these things up together, and when I did that, I got a molar mass of 74.10 grams per mole. More importantly, that meant that every 1 mole of calcium hydroxide is equal to 74.10 grams. So we went through the conversion exactly like how we did it here, and we have this. We cancel out grams of calcium hydroxide on bottom, and we're left with, on top, moles of calcium hydroxide. And this is really, really important that we do this step first. This is steps 1 through 4. Again, just like we did last time, we can put 74.10 associated with grams to every 1 mole. Now, we have to keep in mind this. Our next conversion, we are going to cancel out moles of calcium hydroxide. And on top, we can go to formula units. Now I'm going to abbreviate formula units as form units of calcium hydroxide. I'm going to write that small here, calcium hydroxide. And on top, or think here, remember, I'm going to write this up top, 1 mole equals 6.02 times 10 to the 23rd form units. Okay, so 1 mole is equal to 6.02 times 10 to the 23rd form units. Now, one thing I did differently than the steps is I put everything together here. So what I'm going to do is I'm going to multiply everything on bottom, divide it by everything multiplied on top. So what I'm going to do is I'm going to take 325 times 1 times 6.02 times 10 to the 23rd. So I go 325 times 1 times, very important when we have scientific notation, we put it in parentheses. So 6.02 times, times 10 to the 23rd, close the parentheses. I then press enter. I get this big value here. I then divide it by everything multiplied on bottom. So I hit divide, key thing here, parentheses. So we have 74.10 times 1. Close the parentheses, we press enter. So we have in our answer here 2.64 times 10 to the 24th formula units of calcium hydroxide. So again, that is 2.64 times 10 to the 24th formula units of calcium hydroxide. So what this did is it put everything that we talked about from section 2 with everything we talked about in section 3, and it morphed it into one particular problem. All right, so there was a lot of math on this particular section. This is a major concept in chemistry. I hope you have learned a lot, and as always, subscribe.